Hello, everybody, and welcome to our meetup for GDG Zagreb. I hope everyone is doing well. And today we're going to be joined by Nish from Charlottesville. Nish is a senior staff engineer at Tree, one of the largest agencies and best agencies in the US regarding app development, I think.
Yeah, I think it's fair to say.
Yeah, it's biased. It's biased.
Definitely biased.
Yep, yeah, wait, sorry. Just a moment, I'm getting a feedback loop. Anyways, he's going to talk to us about animations in Flutter, and we're gonna try and keep this more of a discussion format. So if you have any questions, feel free to ask them in the chat, and we'll ask Nish about it. And Nish, I'll leave the floor to you. So go.
All right, cool. So let's kick this off. Cool. So I hope you guys can see my screen here. All right. So thanks, Ian, for the introduction. Yeah, my name is Nish. So I'm a staff engineer with Tree, like you said. We are a digital product agency based out of Charlottesville, Virginia, but we've got some other offices around the U.S., particularly Durham, North Carolina, and Columbus, Ohio. We primarily focus on kind of mobile apps and web, although we do kind of do some backend as well. So we work with Fortune 500 companies to build out some of the best app experiences out there. Feel free to check us out. We are hiring. Awesome. So I'm going to be talking about animations in Flutter. For just to kind of give people a little bit of an introduction, if you're not familiar with Flutter, it is a UI toolkit by Google for building native apps. So we're talking about like fully compiled native to the platform. It targets mobile, web, and desktop. Mobile is in bold here because like that's probably the most fully baked solution right now. Web and desktop are still kind of incubating and still, there's still a lot of work to be done there, especially on the web. One of the key things about Flutter is that it builds from a single code base. So the goal is you essentially just have one code base for your entire application across all these platforms. And then you compile for the different targets. So it, has native performance, and it's built, you build your apps in a Dart programming language. For better or worse, Dart still kind of needs, it's definitely got some rough edges, but it is pretty simple to pick up if you're familiar with Java or TypeScript or Kotlin or C#. There are a lot of very similar paradigms there. So it has a very low learning curve. And one of my favorite features of Flutter is definitely the development experience. Like you get that same kind of quick, instantaneous feedback that you do on the web with their hot reloading feature. So it's basically like the your typical workflow would be try changing some property on some widget somewhere, save, and then you basically just instantly see the changes on your mobile device. That's coming from an Android background, that is definitely a huge time saver. Like you don't wait for Gradle builds to see updates. It just works. So, kind of thinking about it, like what makes Flutter different from something like, React Native or Ionic or any of the other like web-based solutions. Flutter is built, like they basically rewrote their own, they wrote their own rendering pipeline for Flutter. And this pipeline kind of works directly with the platform to natively draw pixels on the screen. So they control pretty much, like Flutter controls pretty much everything you see It's not trying to call into native.
Sorry, Nish.
Yep.
It seems like a part of your initial slide is stuck over your slides.
Uh-oh, that's unfortunate. Let's see. Whoa, is that any better?
Nope, we still see the same. Can you try resharing the screen?
Let's see. Try resharing. Let's try doing that. Uh-oh.
Still the same.
All right.
Okay, yeah.
That seems to fix it. All right. Neat. I guess I had a little bit of trouble like picking up what the difference is. Anyway, so yeah, so like so what makes it so fast is, you know, Flutter kind of has its own like rendering pipeline, so they natively like draw stuff on the screen. So it's not calling into like native widgets and stuff like since Flutter kind of controls everything it is that you see, it's able to do that like really, really fast. But what this means is that like, you know, you sort of have to deviate a little bit, or, you know, very significantly from the native platform. And so I don't, you know, it's hard to make the case that like Flutter is for every app, but I think if you have like a pretty strong like brand identity and you would spend, you know, a lot of time kind of customizing native widgets on, you know, whatever your native platform is, there is a pretty good case to use Flutter. So, you know, you have total control. You have a lot more control over all of the widgets and all of the brand design and all that stuff. Oh boy, this is happening again. Okay, so, yep, sorry. This might be a little difficult. So cool. So one of the core principles of Flutter is that everything is a widget. So widgets are pretty similar to views on Android. It's essentially kind of the unit of kind of the most composable thing that you have in Flutter. So you know, your text boxes, your buttons, your you know, your lists, your icons, like everything in Flutter is a widget. And Flutter heavily favors composition over inheritance. So you're not typically, like adding properties or adding features to a widget. You're not going to be extending one view, to kind of add stuff on to kind of add stuff onto that. Like what you're generally going to be doing is you're going to have something like a container, and a container has a child, and that child is going to be a button, and that button is going to have a child, and that child is going to be like your text and everything. So it's kind of going in the direction of sort of the declarative like UI paradigm, similar to what you'd find in like React or Swift UI or kind of Kotlin Compose, all that stuff. So it's a pretty neat way of sort of thinking through a problem. This is so bad. So let's see. So I encourage you guys, if you have the availability, like definitely try it online. There are a couple of solutions that are available right now where you don't have to kind of install anything to get started. I recommend checking out like CodePen or DarkPad. Those are like really great places where you can actually like just throw up some code and kind of watch, the sort of, pseudo hot reloading kind of take place. It is very indicative of like what the real development experience is kind of like. All right, so unfortunate. Cool. So I kind of want to run through what a real app would, or basically like what a Flutter app kind of looks like. So just to kind of break everything down a little bit, every Flutter app has a main function, so you always know where the program starts, which is pretty handy. And then there's this like run app function that you can call, and you basically pass in a widget, which is going to be your app. So screens themselves are also widgets. So the first widget to kind of that gets attached to like the widget tree, that's going to be your root widget, and that would sort of be akin to like your application class in Android. So from there, your app is going to extend a class called either stateful or stateless widget most of the time, and that provides one override, which is build. And so inside of the build method, that's where you're going to be sort of composing like most of your other widgets in there. So in this case, we're returning a material app, which kind of just adds a couple of. So material app kind of comes with like a couple of like theming properties. So things like an app bar, or things like other kind of the nice material like theming methodology of like having your titles be a certain size, or paragraphs be a certain size, and all that stuff. And then you have a scaffold, which is sort of like it's like a container that describes parts of the app. So things like what should the app bar widget be, and what should the body widget be, and does this have a floating action button, and all that stuff. So inside of our body, then this is where you can kind of start to see how composable widgets sort of fit together. So we have a widget here which describes a center, and inside of that, so it's going to center whatever child widget kind of goes inside it. And then you have a container, which is basically just a box where you can define like a width, a height, a background color, and that has a child which is going to be centered within the container, and that's going to be a text that basically just says the word container. Okay, so I kind of want to add a little bit on animations. So just to kind of talk a little bit about them in general. So we're kind of shifting gears a little bit from just basic Flutter introduction. Animations in apps, I think they, when used properly, their purpose is sort of to add, just to convey meaning to the user, right? So you want to give the user just a lot of like some contextual information on something that's going on or something that's happening. A little bit of information about like what is, what they're interacting with, what's it doing. So in the example on the right, I'm not sure if the animation is kind of coming through, but that is the.
I know it's stuck.
Yeah, that's unfortunate. But anyway, like you can try this out yourself. So that's the Google Keep app. So if you kind of click and drag on a card, or if you kind of click and hold on a card, what happens is you sort of see this elevation animation pop up. And so the elevation kind of indicates to the user that that's the card that they're interacting with. And when they move it around, the other cards kind of shuffle into the position that they're going to be. So that's giving the user like a lot of contextual information about like, if I interact with this component in this way, what is the end result of that going to be? What is the end result of that going to be like? So it really makes your app feel alive and very responsive when your user is constantly getting a lot of feedback about what it's doing and what's happening and how these things are sort of interacting with each other. And these don't have to be like really, really big and super flashy animation. I think like having some subtlety in your app kind of goes a long way, like the ripple effect on a button, for example, or the user selecting something and the elevation changes. Some subtle animations in your app can really make can really change the experience from the end user's point of view. And at the end of the day, like really good really intuitive animations. They're just fun. They're just very delightful to kind of look at. In my experience, like looking at analytics for certain things, like we have had apps in the past where interactive components that are really well animated, like some users basically just go in and kind of just play around with those components all the time. So they can be a source of increasing engagement, like when they're used correctly. So you definitely don't want to abuse them and kind of throw animations in there for the sake of having animations, but it should really contribute to the app's like experience. So just to kind of make that, drive that case home a little bit, there's nothing more frustrating than having some loading text that doesn't actually say anything, or it doesn't give you any more information about what's happening. It just says loading and that's it. It's just super frustrating to look at because you're not really sure if it's doing anything. Like, is it stuck? Is the app actually working? And so in a lot of cases, like users would just end up quitting. But since everything is a widget in Flutter, it's super easy to add these kinds of like loading animations into your application. Like there are a lot of libraries that kind of provide like a bunch of like different animations like these, and you can just drop them in because everything is a widget. You just need to pick the right place in your widget tree and kind of just drop in these animations. So I think having looking into the context and kind of providing meaningful context to the user about what's happening, that's a great place to kind of use these things. So like animations can provide like really delightful like interactions to the user. You just kind of need to figure out like what you just need to sort of figure out like what kind of best encapsulates like what your app is doing and what you want to communicate. So like there's a pretty interesting link here that I recommend kind of checking out. This isn't by another agency in the US, but they sort of did this experiment about like how long users are willing to wait when they're provided like different types of animations, and which provide like a bunch of different which sort of communicate the same thing but in like different ways. And so coming from like static text all the way to like you really using a brand as sort of the crux for providing like an animation. Their experiment kind of yielded like very interesting results. Not like indicators that weren't really well animated. Users would just kind of quit out of there like super quickly. So if you had like the static text that just said loading and it went on for a little while and users weren't sure if it was actually doing anything, they'd basically just quit out of there. So it kind of also makes an interesting case, which is that like if you had like an animated like loading indicator, it doesn't actually have to be accurate. It just needs to provide the user with some visual indication that like something is happening. And so it's kind of really nice food for thought there.
Yeah, if I can intersect, do you remember those like old school DVDs?
Mm-hmm.
And they had those DVD loadings that were like didn't hit the corner. Like people could spend hours staring at those. People don't have a problem with waiting and looking at something loading.
Yeah, exactly. And like those those little bouncy like DVD logos, like those are just like iconic in their own way now. People, anyone who spent a lot of time kind of watching movies back in the day, like they would if you showed them that, they would instantly recognize what those things are. So like having like really good animations in your app or platform, that can do a lot to elevate your brand, if used in the right way. Cool. So on to Flutter specifically, there is some support for, kind of speaking a little bit, taking a little bit of a segue from talking about like, using some animation to sort of elevate your brands. I think, the most popular way to kind of do this now on mobile would be through Lottie animations. So you'd likely have like a designer or someone sort of work on your app via, using on your logo with like After Effects or something. So there is some support for this on Flutter. There are ports of Lottie, but a lot, like as far as I know, I could be wrong about this, but like none of these are actually official ports. So these are kind of community led. So there is, not all of them are like fully baked, but there is an alternative called Flare. I've not really spent a lot of time looking into that myself, but it kind of looks to follow the same sort of paradigm that Lottie would, where you kind of design your animation in an external tool and then export it into something that Flutter can understand. But these are some examples. Unfortunately, I can't really tell if these are coming through on the stream, but these are excellently animated using the Lottie library. All right, so I think I'm going to give a try, sharing my screen again. Hopefully, some of this kind of comes through a little bit better.
Okay. Something just moved.
I'm sorry?
Yeah, something just moved as you were closing the browser.
Something. Oh, I'm not sure. Let's see. I'm also going to try to take off the second display. Maybe that might have had a little bit to do with it.
Yeah, I think your connection quality dropped.
Uh-oh, that's unfortunate.
Yeah, that could be it.
All right, so how's it looking right now? Like, can you, are the animations coming through? Or... All right. Cool, so I'm going to take that as a yes. Are like the animations are coming through this time?
Yep.
All right, awesome. Okay, so kind of moving on. So onto a little bit more, more Flutter animation stuff. So they're generally, you can kind of group animations in a bunch of different ways. For the purpose of this talk, I'm going to kind of group them into like two different parts. So we've got tween animations. So these are like the most common types of animations that you're going to see and likely work with. The point of a tween here is sort of so you define a beginning and an end state, and you want the system to kind of fill in the gaps, right? So this is sort of like working with the interpolator on Android. It's going to follow a curve which sort of which would kind of tell it what the timing and speed of the animation should sort of look like. And then there are physics-based animations. So these are the ones where, these are a lot more interactive. So think of like a component on the screen where the user kind of drags something and it gets very springy, or like, if you worked with iOS, the scroll kind of bouncy effect where when you scroll to the bottom of a list, it still kind of over scrolls, but it gets a lot more resistive. So sort of like the spring that the user is kind of pulling against before snapping into place when they let go. So these are going to generally react to some kind of gesture. But in this presentation, we're going to focus mostly on like tween animations. So everything is a widget. So animations sort of come in widget form, particularly for the first case, which would be implicitly animated widgets. With explicit ones, they're a little bit more involved, but let's take a look at these two and kind of break them down. So an implicitly animated widget will generally focus on like tween animations, right? So the controller for the animation, the thing that kind of works out the timing and stuff, is generally built into the widget, and you don't kind of interact with that as much. And your animation is going to be kicked off by some property on the widget changing. So we're thinking maybe it's size or color or rotation or position on the screen. Those would be the things that would kind of kick off the animation. So you don't explicitly tell it where to start. So that's where the name implicit kind of comes from. And these are generally going to be simple animations. They're not going to be looping or They're not going to be discontinuous. So you give up some control, but for a lot of convenience. And we're going to look at that a little bit more in a second. Explicit animations are kind of the opposite of that. So this is a situation where you want a lot more control over how the animation works and what it does. So you provide your own animation controller. You explicitly tell it when to start and when to stop. You can do things like, provide create a discontinuity in the animation, or kind of use this to sort of chain and sequence like a bunch of different animations together. There's just a lot of power there. So let's take a look at how implicit animations are defined and how they work. So hopefully the animation on this side is coming through on the right side of the screen.
Yep.
All right, awesome. So cool. So this is kind of building off of the example app we looked at a little bit earlier. You've got a container which has a child, and which basically has a child, which is going to be the text. But on the container, we're providing a transform. So the transform is kind of what you'd be using to change things like the rotation or scale or translation and that kind of stuff. So over here, I have a little floating action button on the right side, and I use that to toggle to change some state. So on there, what that tells me is, what that kind of tells the widget is that, like, hey, you should apply this collapsed transform, when this Boolean flag is set to true. So what we end up with is, let's make this guy go away. So what we end up with is, this little animation here, or not animation. This basically just like snapping between frames. So on one frame it's straight, and on the other it's kind of like rotated a little bit. So let's add some animation there. Let's make it look nice. So all we really need to do here is swap out container for animated container. So animated container, what that does is we have to provide a duration, which is to tell it how long the animation goes for. But that comes with a very simple linear curve, which will kind of interpolate the position over time, right? So over the duration that we mentioned. So that we end up with this nice, smooth transition from it being, not rotated to it actually being rotated. So a super powerful feature that we can control there would be the curve. So that's similar to the interpolator. This kind of tells it what the nature of the animation tween should look like. And so different curves sort of, they introduce a little bit of a different, kind of transition animation, if that makes any sense. So you'd notice that, like, on the right side, where we have these little curves kind of playing out, some would get to the end of the animation a little bit or a lot faster than some others. So it's sort of like how much rotation. So in our case, in our specific example, like how much rotation should be applied over time. So it always goes from 0 to 1 as far as the tween is concerned, and the curve would sort of just provide that like X value, which is just how much rotation gets applied. All right. So we can adjust our animation over here by adding a curve to it. And so let's add a bounce out curve. And so now it sort of, as the animation is being applied, like once it gets to the end, it does like a little bounce, which kind of gives it a nice little feeling that the box, is actually like interacting with something, or, there's something resistant there that like it's kind of bouncing into. So you can actually make your own curve. So, we kind of understand like what exactly, or, we understand that like there needs to be a value which is changing over time. So there are a couple of ways that we can do it. One would be if we provided a new cubic curve, or we extend the curve class. So a cubic curve is a it's a Bezier curve. So that since it's cubic, it means that we have 4 control points that we can kind of adjust. So on the right side there, I'm kind of playing around with a curve simulator. So the x-axis here is going to be like our time axis, and then the y-axis is going to be like the x. So it's really easy to work with. It's easy to define. There's a lot of flexibility here, and this is something that I can imagine like handing off control over, kind of adjusting the line here to your designer. And they can play around with this until they get it just right, and feeling like something that feels like really excellent in your app. There is also a great website I found, which is appropriately named cubicberzier.com. You should absolutely check that out. You can play with it and kind of see like what the outcome, if this were applied to a widget, what would this animation kind of look like? There are a couple of like curves that are predefined that you can use as a comparison. So in my case, like I was playing around with this, so like kind of dragging things like off the axis and a little bit off screen, but you can kind of see how this little pink box here sort of follows the curve. So it's like it springs back a little bit, and then quickly like jets to the other side, and then springs forward slightly. So it's kind of looks like a nice Saturday morning cartoon character when they're kind of dashing to where it is that they want to go. It's like that little like backpedal a little bit, and then they kind of just zip forward. I think it's pretty fun.
Wait, you can export the curves here?
Yeah, so the curve is actually just these 4 values up here. So that kind of defines like the 4 points, on the Bezier curve. So it's really like it's really just these values, and you can adjust them by hand if you want. But it's really nice to kind of to get some visual like way of sort of seeing it on the screen and kind of interacting with that.
Yeah, easier than just guessing magic numbers.
Yeah, exactly. Because like hey, one, some yelling at this at someone doesn't really mean a whole lot. It's like negative 0.76. Like, cool. So yeah, you can check it out in app. So applying it to our application over here is just really simple. So it's just like cubic with these 4 values, and you can kind of see the output of that. So like it might be a little hard to see this over the stream, but like try to see if you can spot like when it kind of springs back a little bit. So it's like right there. So it's like springs back a little, zips forward, and then like springs forward a little bit there.
It's coming through a bit choppy.
Yeah, but I'll try to make these available later. So if anyone's curious, like you can kind of browse there and kind of see these at their full resolution. All right, awesome. Neat. So the other alternative would be for you to extend the curve class, right? So in this case, like you're not working with a cubic Bezier curve, you're going to be providing your own transformation function. So what that looks like is right here. So we just extend the curve class, and then we override this transform internal function. So what this kind of tells it is like, what you're providing over here is you're kind of providing like the value, what we had as our y value, the y-axis value on the curve. So this function in here can be anything. So in this case, like at every point in time, we're just returning the same value. So what that's going to give us is just like a straight line, like linear transformation. So just like very monotonously, like just travels along the path. But you can get as complicated over here as you want. And so this is just me kind of copy pasting like the transformation function that was placed into the elastic out curve class. And so, I'm not going to get into the math here. I'm not even sure that I understand this. But It's just to kind of illustrate that you can like get as complicated as you want with it. So, feel free to graph this, try to follow it over time, come up with something that kind of works for your specific use case. Yeah, so applying these is really, really simple. You just replace the curve value that we added to our container earlier, and it just kind of works. Yeah, and to kind of add to that a little bit, most of the curves, or pretty much all of them, kind of follow these, like they're the ones that come built into the Flutter SDK. These all, most of them are like cubic curves, and then a couple of them have their own like custom transformation function. So, like, in my opinion, I think you might be able to get away with using cubic curves for most of your use cases, but there are definitely times when you might want to kind of extend the curve class and define your own function. Right, so we've been playing around with animated container, which, so it has a lot of properties that can be implicitly animated, but there are things that, like, sometimes there are some things that might not be able to be implicitly animated. There are some properties. So there are a lot of other implicitly animated widget classes, animated align, animated opacity, animated padding. There are a lot of great resources on how these work and how you kind of use these. So, for the most part, like, I think these are really powerful, and having these really adds a lot just by themselves to the quality of your application and how responsive and how they feel. But there are times where there are things that there are properties that you might run into that you would like to animate for your use case that you might not be able to. So right, so I'm asking a question. So what if there isn't an animated widget that works with what you have? There is a component built in called Tween Animation Builder. And so what this allows you to do is specify your own kind of custom animation tween that you can apply to your own widget. So this is great for building your own implicit animations. And it's really easy to implement too. So you basically just wrap your container. So I kind of took off the animated part here in this Tween Animation Builder, and then you specify a tween. So in this case, we're using a color tween because what I would like to do is animate between two different colors and a duration, and then kind of forward that along to your along to your widget. So those would be these parts over here. And so then you end up with this nice tween between the colors whenever I click on the floating action button. All right, so over here, so when I click on the floating action button, that kind of that basically updates the target value. And so then it kind of tweens between these. So if you wanted to add a little bit more customization to this, you could optionally make this target value dynamic. So maybe the user gets to pick what colors they want from the list, and the tween animation will kind of do the work of going from whatever the beginning color or the current color is to whatever the target value is. So that is generally a one-way thing. Always attempting to tween from beginning to end. It never goes from end to beginning. So updating the beginning color here wouldn't really do anything. All right. So I'm not sure if there are any questions coming through, or if you've got any questions.
But what if you want to control animations on an event, like on long click press, like depending on how the user has pressed the button, how long does it actually go deep or bounce? If you understand what I mean.
I'm sorry, no. So let me try to repeat the question. So like, if you wanted to control the animation via a long click.
Yeah, user interactions.
Mm-hmm. Yeah, so in this case, like what the implicit animation engine kind of cares about is just whether or not a property is changed, right? So if you're able to change the property that you would like to animate to using a long press or using a button click or some kind of gesture or whatever it is that you have in mind. All that, like, the most important thing is that, like, at some point a property on the widget changes. So in this case, like, I'm kind of working off of just a regular button click, but this could easily come off of the container itself, right? Or this could easily come off of some other widget on the screen. So the most important thing is just that some property value gets updated at some point in time, and that kicks off the animation, and that will basically cause it to follow the tween.
Yeah, what I was asking is like if you could like control the amount of the tween by, I don't know, like having a slider. Does it have like a property you can change or you can pass in as an argument?
Oh yeah. So yeah, that's an excellent use case. So the slider would just update the target value, and that's it. That's all you need to do.
Easy.
Yeah. Surprisingly easy.
For Android.
So yeah. So yeah, that's why I think implicitly animated widgets are just, they're extremely powerful, and you can get by doing a lot just with these. And so, like, kind of really thinking through, like, what sort of subtle animations you want to bring into your application. Like, I think you can get really, really far just kind of, intentionally, like, sprinkling these across your application.
Basic bounces and buttons.
Yeah, exactly. Maybe add a little bounce to a button here. Maybe add, a subtle change in elevation when the user selects something, or maybe change the size of a container as it's being removed from the screen or something like that. Like, there's so much that you can actually do that can add just a lot of value.
Yeah, the good thing with widgets is you can basically standardize it across your whole app and have like a whole animation language, like a motion language.
Exactly. And and this is something that you want to talk to your design team about. Like, like, for the most part, like, animations have been, or continue to be, a rather difficult, like, challenging thing on Android and iOS, and to some degree iOS. And so a lot of designers might shy away from that. But if you're working in Flutter, kind of the rules for what the threshold for, like, a difficult animation, I think kind of moves down a little bit. So being mindful of this, maybe not pushing it off until the end, might actually, like, I think that would yield a lot of gains for development teams.
Like, yeah, if you plan your trees, depending on how you're gonna animate, you're gonna save some refactoring later, probably.
Yeah. Yep. Exactly. How you plan out your trees. Just how you like, kind of, as that's being incorporated into your app's design language, basically, right? It's not like it's going to feel a lot more natural. Not something that gets tacked on in the end, where you're like, oh, I could animate this. It might look cool, doesn't quite fit. But that's a consideration that's sort of been made from the get-go as you're sort of building these things up. As you kind of look at these things over and over again, you're spending a lot more time kind of refining these and making them fit a lot better with your application. All right. To kind of jump into explicit animations here, so just to kind of recap from earlier, these are animations where you have a lot more control over sort of when the animation starts, when it ends, how it ends, whether or not it plays backwards, whether it repeats. So that's where you're explicitly kind of taking control over a lot more features of the animation. So there are generally going to be three components that you would be looking for and working with here. So the first is going to be the animation itself, the animation controller, and then the ticker. So I'm going to kind of dive into these in context, just to kind of illustrate how they work. So we're going to start off with just the base app that we've kind of been looking at. So right now I stripped out all of the implicit animation parts and also the floating action button, because we don't really need that here, since we control since we have a little bit more control over when the animation gets kicked off and stuff. So the first thing we're going to add is an animation controller. So this is going to go in on init state. On init state is very similar to component did mount on in React, so this gets called after once the stateful widget sort of gets once the stateful widget is getting initialized and when the state is about to be built and stuff. So you get to do a lot of initialization work here. So what we want to do is initialize the animation controller. So this is going to take a duration, and this is going to take this vsync property here. So the animation controller is responsible for starting and stopping the animation, playing it forward and back. Also, it gets to define some of the upper and lower bounds of kind of the tween. We'll look at that a little bit more in a second. But this also requires a ticker, and that's what the vsync thing is. So let's give it a ticker. So the ticker is basically just like a little timer, right? So it's just constantly ticking every frame, and it's going to pass in the ticks to the animation controller. So that sort of tells it that's what it uses to kind of figure out when to increment its internal values and all that stuff. So the most common pattern for this is basically to add this ticker mixin. So if you're not familiar with mixins, it's sort of I want to say they're a weird cross between an abstract class and an interface. It's a way for you to sort of define some external behavior and then kind of just graft it on to a class. And so mixins are really powerful. So in this case, it just comes with the capability of having a ticker, basically, and that's how you add it to your class. So the next part about this is going to be the animation itself. So in this case, we're initializing this with a tween, so very similar to what we had with the implicitly animated widgets. So explicitly animated widgets can do pretty much everything implicitly animated widgets can do, and this is generally why, in my opinion. So you pass in a tween, and so this tween value here is what we're going to be using to sort of define. We're going to be using this to kind of as properties that we're going to be passing into widgets. Animations can also attach listeners, and these listeners kind of, so in this case, you can listen for things like the animation state, or if you're interested in things like whenever the animation value has changed. So in this case, we're using that to force the widget tree to rebuild. So whenever set state gets called, the build function is going to get called again, and then the Flutter engine will figure out what parts of the tree need to update. All right, and so here, the next part of this, what we're doing here is we're basically telling the animation controller to actually start the animation, right? So telling the controller to kind of go forward, what that says is start. So your internal animation tween is going to start at 0, so you want to kind of push that forward to 1. So that's going to move the animation tween, and that's going to update the animation values, which we want to update the animation value, which we want to kind of pass on to our widget. So over on the right side, there's a little GIF going about what we should be seeing at this point. Even though it's looping because it's a GIF. It's not looping because like that's what it would actually do. So what would happen right now is, since we're kind of defining the tween, it will start from value and then kind of grow so as the animation controller kind of moves the animation forward, and then it's just going to like stop. So if we want to actually get to what it is that we're actually to what it is that we're seeing right now, what we need to make a couple of changes. But one other thing is, since you have a lot more control over like what it is that's going on, you need to remember to dispose the animation controller, or otherwise you're going to create a memory leak. All right. So let's kind of make a couple of changes here. So I'm going to add a status listener. So what I'm listening for is the status of the animation. Like, are you completed? Have you kind of gone, like, so in this case, like animation status of completed would be the animation has gone forward all the way. And animation status that dismissed would mean that the animation is sort of reversed all the way, right? So we're going to listen for these. And then we get to tell the controller what to do next. And so this is something that you really can't do with implicit widgets. But so we get to tell the controller, hey, so once you go back all the way, kind of go forward all the way again. And once you go forward all the way, reverse the animation like back to the beginning again. So then you end up with like a nice like infinite loop. So if you wanted an animation that loops, here's how you do it. All right. So any questions so far? Uh-oh. Am I still connected?
Oh, yeah. Sorry, I was muted.
All right.
I don't have any.
All right. Awesome. So yeah, so it kind of looks good so far. So you can actually have multiple animations going at the same time, and these can share an animation controller. So if you wanted to sequence a bunch of different animations, or a bunch of different properties changing either on the same widget or on a bunch of different widgets, you can actually have as many of these sort of chained together as you wanted, right? So in this case, like I'm adding a second animation, which is going to be the color animation. And what this would do is, so kind of in tandem with the size changing, the colors will end up changing as well. And so if you needed something, so in our case, like it grows and shrinks and kind of changes color as it grows and shrinks and stuff. So that's super easy to do. All right. So, we've kind of taken a look at a bunch of different things that we have. We've got like, some implicit animations. We've also kind of looked at some explicit animations. So these are really powerful when you kind of start to combine these things and sort of use them together with a bunch of other widgets. And so what I'm going to be doing here, and like this is a lot of code to go through, but we're going to kind of break this down, but just to kind of take a look at where it is that we're getting at. So if you look at the animation on the right side of the screen, so we've got these cards that are in a stack widget. So a stack widget is basically just like, it's just exactly what the name kind of hints at. So it's like a bunch of widgets sort of stacked on top of each other. And you can actually say what position something is in the stack. And by position, I mean, also like kind of where it is in the stack, but also like where it's actually drawn. So if you kind of look, there's like a little bit of an offset on stacks that are underneath. So they are slightly smaller and kind of pushed down a little bit. So it kind of gives the user the illusion that like these things are sort of stacked together in like 3D space, even though they really aren't. So yeah, so app design and animations all just like smoke and mirrors. So yeah, so we can swipe these, and then what we're going to be trying to do is sort of kick off an animation that sort of changes their position on the screen. So it's going to animate them going to the side, and then it's going to animate the widget underneath, kind of moving into the place that the previous card was, right? So there's like a lot of these things kind of chained together. And then there's also this animation on the background. So it's changing with whatever card is currently at the top of the screen. So we're going to kind of look at how that works as well. So kind of putting it all together. All right. So explicit animation here. So we've got sort of the same thing. Our animation controller. We're using an animation curve to sort of help define. We're using a curved animation here to sort of help define like what the tween is going to look like between some of these elements. We've got a translation animation there, which is going to help take the card off to like this off screen basically. A scale animation, which is going to help like change. So it's going to change the scale of the card. So it's going to make the card that comes in and takes its place like slightly bigger. And there's a move animation with that, so that the card kind of moves like into position. And that makes any sense. So we've got all of these animations kind of going on there, and all of these are sort of working off of the same animation controller. So they have like the same, so they're going to be working with the same ticker. So that's how we're going to kind of synchronize all these things together. And so that's the stack where all of the cards are kind of placed. And so we're working with something called a gesture detector. So that's the widget that's going to be responsible for letting us know when the user kind of drags onto the screen. And so each child is going to have a translation property. So this here kind of gives us a transform widget that's focused on translation. So we're going to get the flick. Gesture. We're going to we have to do a little bit of math, which I'm not going to get I'm not going to get into here to figure out like what the offset of that card is. And then we have this fractional translation widget, which is really good at kind of telling, sort of allowing you to define kind of fractional, basically like it's really good at helping you define like where the widget should be placed. So if you wanted to add like little offsets onto it, it's really that's a really handy widget to have. And then we're going to apply the scale. So the further back you are, the smaller you are. And so that's kind of how we achieve that little like illusion there. And then right in the middle, then we actually add the card and the card content and stuff. All right, neat. So once the drag, so when we actually get the drag, callback, so the user has kind of swiped the user has kind of swiped already. So what we're going to do is we're going to kick off the controller. So we're going to tell the controller, hey, what we want you to do is kind of start the ticker, and that's going to kick off like all of the other animations. And when you're done, then we want to reset the controller so we can do it again, basically. So once the animation is done and the swipe is done, then we kind of move, like the card should be off screen at that point, and so we can remove it from the card stack. So I've also added a callback here on the parent widget, and what this is going to be used for is sort of notifying the parent that the card that's in focus has changed, right? And so once that card changes, then what we're going to do is we're going to change the background color. So in this case, like I'm picking a random color. That's why, between card 2 and card 3, there's the background kind of stays the same. It's because it's kind of picking it at random. And I found that no matter how many times I tried to record this, I would always get a collision. So I'm not sure if that's just my luck or if, it's just stats. I'm sorry?
You should go gambling.
I should go gambling. So we're going to be changing this BG property here. And what this is going to do is this is setting the property for this animated container. So now this is where we have our implicit animation, right? So something happened that triggered a change in the property. And so the implicit animation controller kind of takes over and basically just updates the background for us automatically, which is super great. And it does the tween, and we can provide how long we think that animation should take. And so you'd want to make sure that that's like synchronized with the other animations that are kind of going on the screen at the same time. All right. So something that I didn't really get to touch into, which we started talking about off screen a little bit, off air, was how would we actually what would you do to kind of architect something like this to make this a little bit more manageable? Because this is a lot of code, right? So there are a couple of classes that kind of act as helpers, which unfortunately I didn't prepare some examples of this. But there is the animated widget property, which will kind of allow you to bundle animations like these into, or an animated widget class, which will kind of allow you to bundle animations like these into their own like single component. So that allows you to sort of split off the animation controller from the actual animation widget itself, which kind of makes things a lot easier to manage. Because in the spirit of declarative architecture, what is going to happen, what will likely happen anyway is you're going to end up making your own you're going to end up making a lot of your own custom widgets. And these are going to sort of be composable with everything else. So you would be able to kind of make this, you'd be able to make this like a reusable widget that you can kind of apply to other stuff in your application as well.
Yeah, so basically baking your own UI animation kit.
Yeah, basically you'd be baking your own UI animation kit. Which I think is fine. It's not like once you actually start putting these things together, it's not really as messy as you'd think. But what does get pretty complicated sometimes is when you have like sibling widgets. So kind of widgets that are at the same level in your widget tree. When you want one of those things to kind of kick off an animation for another. So that's where things like kind of writing the binding for those start to get a little bit complicated. But I think, really kind of taking a step back and kind of looking at the bigger picture, you'd want, at that point, like you should really be asking yourself, like, should these sibling widgets actually be nested widgets? Like, is there a way that I can nest these to make them a lot more composable? So those are like that's generally the type of issue that I kind of run into. And in my experience, like that typically happens like when you're trying to like go back and kind of retrofit an animation into an already existing like widget tree. But yeah, there's some pretty good solutions for kind of how to get around that kind of stuff. All right, so cool. So transition widgets. So with implicitly animated widgets, there's like, there were a lot of like kind of built-in widgets that we could take advantage of. The same is true for explicit animations too. For implicit animations, the widgets were typically like, animated container, animated opacity, animated, something. But for explicit animations, those are typically going to be transitions. So in our case here, so looking at this, so when you click on this, we're kind of moving the nice big Flutter logo in the animation stack, or in the stack widget, and we're doing that via this positioned. We're doing that via this positioned transition. We're doing that via this position transition widget here. So let's take a look at how this animation. How this works. Let's break it down. So cool. So we have our animation controller, with our explicitly animated widget. That's pretty normal. But what we're doing here is we're using this relative rect tween. And so what this is going to do is kind of provide an animation tween between two positions kind of in the stack, so two rectangular positions. And that's going to get applied to this positioned transition widget. So this is going to take a rect, which is going to be the tween animated by the animation controller. And so when we tell the controller to go forward or go back, that's going to kind of kick off our explicit animation there. And so there are a bunch of these, and they're pretty convenient and super easy to use. So yeah, position transitions, we got things like rotation transition and things like decorated box transition. So that's useful if there were things about like your container that you wanted to animate, like drop shadows or the color or that kind of stuff. So there are a lot of these. These are a little bit harder to search for than the animated container type widgets, because the transition is kind of at the end. But they're pretty useful if you can kind of spend a little bit of time looking for them. All right. So cool. So we got all of this stuff in here. So how do you pick the right animation for you? So there's this really awesome flowchart that was made by Emily from the Flutter team. I recommend kind of spending a little bit of time kind of looking at this. It's got it's pretty small, but it's got a lot of information kind of packed in. So the general gist of it is, if you have a very simple animation that, where you don't really have any loops or discontinuities, you probably want an implicit animation. And if your animation is kind of, a little bit more complicated that way, you would likely want to set up an explicit animation. But if you're kind of working on, trying to animate a thing that has like a lot of different pieces, or it looks like, a drawing that someone is kind of animating, like something that really should be a sprite sheet, then you want to kind of grab Lottie or Flare or something else to export that into an animation that you can use on Flutter. And for explicit animations, if you're having like, if you're having performance issues, then you likely want to kind of work with the custom painter to set up, like to basically draw your animation directly onto the canvas, skipping a lot of the stuff that widgets would typically do. Cool. So, I kind of shared a lot of stuff, and I hope this was like a pretty good like introduction into what animations kind of look like in Flutter and how a lot of that stuff works. But there are a lot of things that I can't cover in just a day. Like I think, talking about animations could probably be like its own course or book or something, where you kind of get into like the nitty-gritty detail of like how every piece of it kind of works. But things that I think that, would be worth your time to kind of take a look at would be, what the explicit animations on using the custom painter. So if you're going to working with the canvas directly, shared element transitions, sort of like are on the little GIF here. I think these are extremely powerful, and a very like they're like a very sort of they're a very big part of like the material design spec. And so, if your app uses material design, then you probably would be very interested in like how to set these things up and stuff. And also hero animations. So, very similar to shared element transitions, but like going from a really small image somewhere to like a really big one, and how to coordinate that. That might be something pretty cool. Cool. So that's basically everything that I've got. I don't know if there's any time for like Q&A and stuff, or if there are any questions that people might have that we can kind of talk about.
There's no questions in chat currently. We can wait a minute to see until it syncs up with the video.
Yep.
Yeah, but thanks for the talk. It's a really great introduction.
Yep.
Yeah, I feel like adding just like transition animations, like shared element transitions and simple button feedbacks, is a way to like really simply add a ton of, I don't know how to say it, pleasant UI to your app.
Yeah, I think so. And going with like a lot of those, like just really understanding like a lot of the implicit animations that are available to you, like just right out of the box, that can go a long way. Like those are things that they might be really subtle, but like they just add like a lot of like they add just a lot of life into your application.
Yeah, we got a question on the chat. What about real-time event-based animations, like moving an image based on accelerometer events? What would you use?
Moving an image based on um, accelerometer events. So I think for those, you might be able to get away with kind of using well, I guess it depends on the nature of the animation, right? So if you wanted something that was just that reacted in real time to something going on. So thinking of like I don't know what that thing is called. Like, if you've ever seen like on an Apple TV, when you play with the remote, they have like this like nice little, they have like this card animation that sort of reacts with the user's finger. So something like that, I think you might be able to get away with like an implicit animation. So you would just have the accelerometer feed into the widget's transform property, right? So you would add a little bit of a rotation. So the matrix 4 class would allow you to kind of do something like that. So you'd add like a little bit of a rotation to the animation, or to the widget. So that would work. I think that would work there.
Yeah, just passing down the state from the accelerometer.
Yeah, exactly. And then you would probably want to do some like normalization of the data, but then that's where like some of the tween classes might be able to help you.
Oh yeah, that's especially with accelerometer, you're gonna get probably data all over the place depending on the sampling rate.
Yeah, exactly.
Yeah, I was working with it recently, and oh god.
Yep.
I don't have any more questions, and I don't see anything more on the chat. Well,
yeah,
it was a really great talk. I'm sorry some of the animations got chopped up, so we couldn't see everything.
No, that's okay. Like, I'm glad that we kind of got to like I'm kind of glad that things started working out a little bit better. Further into the talk, but yeah. So one more thing I will say is that I am on Twitter. So feel free to shoot me or tweet me questions if anyone if you have any, or if anybody has any. I'm super happy to kind of take those there. But yeah, like I hope if you haven't worked with Flutter before, this kind of gives you or kind of inspires you a little bit to at least take a look at it. I think it's a pretty cool platform, but like I said, like there is a lot of nuance there. I don't think this is like the one platform to rule it all, but it's getting pretty close.
I'm not so sure. I'm not so sure.
Yeah, but yeah, there is a bunch of nuance. That this is definitely not for every app, but I think it is still like a pretty good playground to kind of play around with.
Yeah, that too. But I think especially with some animations, it depends because users on iOS are used to different animations and different properties than Android users.
Yeah.
So like, yeah, if you have a ton of custom animations, as you said, Flutter would be a great choice. But platform-based, like maybe making specific platform animations.
Yeah. So like on specific platform animations, like at least in my experience, I've not had a lot of reason to do that yet. Some of the widgets do come with, platform differences built in. Like if you ever use any of the scroll widgets, they would typically add the spring animation on iOS, and then they would add like the over scroll indicator on Android. But in your own code, you might want to add platform checks. If iOS, render use a different tween for the animation versus Android, depending on what the needs of your platform is.
We got a question about the editor, the Flare editor. Have you ever used it?
No, I have not used it, but just kind of going over and looking at the demos and stuff. That's really all I know about it. I mostly worked with Lottie in the past.
No, I haven't tried Lottie on Flutter yet.
Not in Flutter, on Android, but like I mentioned, the packages for Flutter, those are still kind of incubating and in beta somewhat.
Oh, yeah, so better take care of that.
Mm-hmm.
I think that's it for the questions. So thank you a lot for the talk. It was great. You really went in depth.
Yeah, thank you. Appreciate it.
And I hope to see you again another time.
Hey, possibly. Thanks for inviting me. I appreciate it.
Bye-bye, man.
Yeah, see you.